Now we're doing some more trig questions here, but this time we're trying to find out an unknown angle in a triangle. Now the important thing to realise is the steps are exactly the same steps that we were using before in the previous question. So in the case of this one, the first thing that we'll say to ourselves is which sides are involved. And it's the opposite side and the adjacent side. That makes it a tan question. Tan of the angle we're trying to find out, that's Greek letter theta, tan of our angle theta we're trying to find equals opposite over adjacent. 8.2 divided by 3.1. Now 8.2 divided by 3.1 is just a number, and I think it's probably a good idea if we evaluate that as a number right now on our calculators. So it's 8.2 divided by 3.1. 2.645. Use an extra decimal place or two here is a good idea until you get to your final answer. Just leave it like that. Now, the tan of angle theta equals that. I have to find out the angle that's got a tan value of 2.645, and I can do that using inverse tan on my calculator. So on my calculator, I'll go to my trig functions, and you'll see inverse tan. It's often written like this on your calculator. It might also be written as INV tan, but here it is, it's written as tan to the minus 1. Can you see it right there? So I want to do the inverse tan, and what that's going to do, it's going to find out the angle that's got a tan value of 2.6541. Now, if you can use this, it's really good. I've got the previous answer on the screen, so I want to find out the angle that's got a tan value of, and I'll just put there the tan of my answer, my previous answer, because that's going to take into account all the decimal points. And if I do that, I don't even have to close it with a bracket, I don't think. It'll work it out for me. And the answer is theta equals 69.29 degrees. In this course, it's okay to leave your answer just as a decimal like that. Let's do another one. So, step 1 is which sides are involved. In this case, it's the adjacent and hypotenuse. Step 2, which ratio is it that connects together those sides? The adjacent and the hypotenuse are connected by the cosine ratio. So that means the cosine of our angle theta equals adjacent over hypotenuse. 10.9 divided by 14.2. I'm going to change that 10.9 divided by 4.2 into a number simply by going 10.9 divided by 14.2. And we get cos of theta equals 0.7676. I want to know the angle that's got a cos value of 0.7676, so I use the inverse cos on my calculator. The inverse cos minus 1 of my previous answer. I could type the number in here if I wanted to, but there's no need. And so I get theta equals 39.86 degrees. My last example, and it says, I'm saying to myself, which sides are involved? The opposite and hypotenuse. That makes it a sine question. The sine of angle theta equals opposite over hypotenuse, 500 over 824. That means the sine of theta equals, and I'll change that to a number, 500 divide by 824. Sine of angle theta equals 0.606. Rounded off. Doesn't really matter because I'm going to use the whole of that number on my calculator. So that means that theta is the angle that's got this sine value. I can use inverse sine on my calculator. Inverse sine of my previous answer. Didn't come up there. Inverse sine of my answer. That's better. Oh, I did work it out because it's just covered up, isn't it? There we go. 37.32. So 37.36.